a webinar sponsored by the Climate Smart Conservation Learning Initiative, and here's what we are going to do with you all. We had a little exercise for people to do as they joined. We called that the Do Now exercise. We're going to give you a little overview of what we call the building blocks for climate resilient situation models. I'll start with that overview and then hand it over to Ryan. And then we're going to organize our breakout groups. We have been working on building blocks for several different ecosystems, and so we're going to ask you guys to choose an ecosystem or group of species for the breakout groups. Then we're going to work in the breakout groups for about 40 minutes, and then we've got a closing discussion. And in that closing discussion, we have a question for you about what we should be doing next, where we should be going next with this product. So without further ado, let me put this actually into slideshow mode. And okay, so we're talking here about the building blocks for constructing climate resilient situation models. So let me tell you a little bit about our learning initiative. So we received funding from CMP and the Moore Foundation to facilitate learning among conservation practitioners who are incorporating climate resilience into their biodiversity conservation work. And the objective specifically of this session is to share a draft product that we put together last year called Building Blocks for Constructing Climate Resilient Situation Models. And I'll explain what we mean by that in a minute. And we're very interested in getting your feedback on that so that we can improve the product and continue adding to it. Whoops. So why is this not advancing? Okay, so who are we? The CMP Climate Resilience Working Group has had a number of people that have contributed at different points. So this is all of us. The people who have worked the most on this specific product have been Barsha Suraj, Ryan Mitchell, and myself, but others have contributed to other parts of our work. A few years ago, we developed a guidance piece called Climate Smart Conservation Practice to explain how to integrate climate change with conventional non-climate threats to biodiversity throughout the design, management, monitoring, and adaptation of conservation projects. And the guidance is based on the conservation standards. So let me tell you a bit about the specific topic for today, which is incorporating climate into situation models. So I think that from what I saw from the people who were joining, that most of you are familiar with the conservation standards. I hope so, because we're not really going to cover the basics. But for those of you who aren't, this is a situation model. And in your situation model, you define what are the ecosystems and species that you're interested in conserving, what ecosystem services do they provide, how do they contribute to human well-being, what aspects of human well-being do they contribute to, what are the threats to those ecosystems and services, and what are the indirect threats and opportunities or drivers. So how is this different if you're trying to incorporate climate resilience? So a climate resilient situation model is like a normal one, but there are two differences. One is that in addition to including what we call conventional threats, sort of the normal threats, illegal logging, overfishing, conversion of forest to agriculture, things like that, we are recommending including climate threats. And where relevant, and this is especially relevant when you're including climate threats, we recommend saying something about the biophysical effects of those climate threats, so including those biophysical effects. So what is a climate threat? if you look at the definition in the conservation standards of a direct threat, it reads as follows: primarily human actions that immediately degrade one or more conservation targets, examples, illegal logging, unsustainable fishing. They also can be natural phenomena altered by human activities, such as an increase in extreme storm events due to climate change. So what we are recommending is basically teasing out that definition and into two different types of direct threats. Basically, your conventional direct threat, which are those human actions that immediately degrade one or more ecosystem targets, so uncontrolled grazing, overharvesting, fuel wood, poaching, sort of your standard direct threats, and what we're calling a climate threat. So natural phenomena altered by the mainly human-caused increase in global surface temperatures and its projected continuation. Things like increased spring precipitation, decrease in precipitation as snow, and increase as rain in winter. So things like that. So that's how we're defining a climate threat. If you go to the CNP IUCN threats classification, version 2, there is a group that's in the process of updating this, but this is the version 2. There's a section for climate threats, and it includes 5 categories of climate threats. So it includes ecosystem encroachments, including like sea level rise or desertification, changes in geochemical regimes like ocean acidification or changes in atmospheric CO2 that affect plant growth, changes in temperature regimes, heat waves, cold spells, etc., changes in precipitation and hydrologic regimes like droughts and increased severity of floods, etc., and severe extreme weather events like thunderstorms, tropical storms, hurricanes, cyclones, etc. If you want more detail, there's a slide that has the link to the CNP IUCN threats classification and includes the section on climate threats. So what do we mean when we say that what we've put together are building blocks for climate resilient situation models? If you go into the Marathi software, Marathi Online, there is a section called building blocks. And many of you are probably familiar with CHAML, which are the building blocks for developing results chains. The same concept applies here. Building blocks are intended to help you to start, so you don't have to start from scratch, to give you an initial, in this case, initial threads of a situation model that you can say, okay, this basically applies to my site. I'm probably going to have to adjust it a little bit, but I'll take it. So in Marathi, there are building blocks for situation models, theories of change, and for performance indicators. For the theories of change or results chains and the performance indicators, there's a bunch of stuff in there. For the situation models, you can see that it says under construction. So the idea is that what we have put together, once we get feedback on it from you all and refine it a bit more, the idea is that it would get put into Marathi Share as examples of threads of situation models that are applicable specifically to climate change that people can use. So if you are working on conserving coral reefs and you're wondering, well, how does climate change generally affect coral reefs? I'm not really familiar with that. Where should I start? You can take a look at the threads of situation models that we have put together. So our intention has been to develop portions of these generic situation models that coaches can use as building blocks when they're working with a team to develop a situation model that incorporates how climate change is currently affecting and is projected to affect conservation targets. So building what we're calling a climate resilient situation model. So our audience is conservation coaches and project teams that are using the conservation standards to help identify how climate change would affect their conservation targets. And while the building blocks will help the coach and the team begin to identify relevant climate threats and their biophysical effects, ideally, the project team would also consult with climate experts with knowledge of their area. So this is really just supposed to get people started. Okay, I'm going to hand it over here to Ryan, who has done a lot of the work on this product, and he's going to tell you about what he has done.
Thank you, Marcia. So we prepared the chains by reviewing literature to both identify the most common climate threats to specific ecosystems based on the CMP threat taxonomy and the biophysical effects of those threats. We thought a lot about how climate threats affect conservation targets directly by exasperating a conventional threat or by acting with a conventional threat on the same biophysical effect. Next slide, please. So for each conservation target, we identified the most important threats, and then we organized them based on the 5 categories of the climate section of the CMP IUCN threats classification, as you can see here. Next slide, please. And then, as you can see here, this is a very generic version of what the chain would look like. The climate threats have red text and are in red boxes. The direct threats have red boxes, but they have black text inside. The biophysical effects are in green boxes, and the conservation targets are in green ovals. And as you can probably see, the shade of green for the ovals is a little bit different. Next slide. And then here is an example of what a climate threat would look like if it was going directly to a conservation target. And then the second one down, of course, is an example of what a climate threat would look like if it was exasperating a conventional threat. And then, of course, all of that goes to the conservation target eventually anyway. Next slide, please. And here's a little bit more of a, not necessarily more complicated, but a little bit more of a built out chain of events. So you have a climate threat and a conventional threat affecting a biophysical effect, which in turn affects the conservation target. Next slide, please. And so I'll let you all look at this for just a moment, but we'll be getting more into these chains as we break out into breakout rooms. But this is basically what it would look like for a specific ecosystem. And we have several chains for all the ecosystems we decided to focus on. And we really tried to balance between putting a decent amount of detail in there, so it wasn't too simple and too bare bones, but on the other hand, not to make it an overwhelming chain. Next slide.
So before we go to the next one, I'll just mention one other thing, which is that where you see these little numbers, this is the literature that that we reviewed, mostly Ryan reviewed, which is in the notes below the slide. So if you guys want to see, well, what article tells you that increased frequency and intensity of storms causes strong wind and storm surge that causes physical damage to mangroves, you can see the articles that we reviewed.
And so as you're looking at these chains in the breakout rooms, you'll probably notice that there's not a lot in there about human well-being. As you can see here, we included human well-being targets when the climate threat directly affects a human well-being target, but for the most part, we decided to not include human well-being explicitly in the chains, not because we don't think that's important, but because we believe that's a separate set of building blocks, and we hope maybe folks like you would be interested in potentially building that at some point. Next slide, please. And then these are the building blocks. We'll be voting shortly on which ones we want to have various different breakout rooms around. And please also give some thought to if there are any crucial ecosystems you think should also be considered. And that's something we can talk about later in this webinar. Next slide. And so,
Okay, so let
yeah,
me, oh, I think I'm taking over now.
for sure.
So let me explain what we're going to do in the breakout groups. As Ryan mentioned, we're going to ask you to choose one of these targets. So think about, you know, which group you want to be in, and we're going to vote to see which ones we work on, so that our groups are like big enough to have some discussion, but not like too big. We could work on all 8. So we're going to ask you to go to your breakout group and go to the slides for your ecosystem or group of species. As a group, you're going to look at the first slide, and that first slide has what climate threats affect this ecosystem. And consider whether we're addressing the most important climate threats that you believe affect this ecosystem or group of species. So see if you think that we've like left anything out. Then you're going to go to the actual building blocks slides, which are below that. And we recommend that everyone take a few minutes, maybe 10 minutes or so, to just read through them individually and think about these questions. Have we represented all the relevant ways that for each one that this climate threat can affect the conservation target, you know, by exacerbating a conventional threat and or acting with a conventional threat on the same biophysical effect? Have we included the most important conventional threats that often interact with this climate threat? And do you think that this chain has the right level of detail? Like as Ryan said, we definitely put some thought into having it. They're supposed to have enough detail that we think people will learn something from them, but not so much that they feel like, you know, overwhelmed by it. But let us know if you think that we got that right. And so after you review these on your own, and we've got some sticky notes in each section that that people can grab and put their comments in there. Then as a group, review the building blocks and discuss the comments. And, you know, let us know if you have any other feedback, but those are basically our instructions. And I wanted to say one thing about navigation, because Varsha Surich put in these links, these boxes that say instructions, introduction, building blocks, that allow you to navigate pretty easily. So they're up here. And if you're in presentation mode and you link to, you know, you hit mangroves, for example, I'm not going to do that right now, but it'll take you to the mangrove section of the slide deck. So easy navigation.